G'day guys, in this video I'm going to be showing you an example to do with reaction forces. So here we're asked to draw the free body diagrams for both massless beams. Here's one beam just here with an external force of 30 newtons acting on it, and it's pinned at this end. And here's another beam connected to the first via a pin just here, and it's connected also to roller supports at C and D. Okay, so it seems quite complicated, but let's break this down nice and slow. Let's draw the free body diagram for this first horizontal massless beam just here. Well, the first external force is easy. We know that a 30 Newton force is acting on it, so that'll pop up just here, right? That's a good start. Are there any other external forces? Well, yes, there's going to be a reaction force at A due from the pin support. And that reaction force, in the general case, will be AX here and AY here. Notice it's a pin, that means there's going to be reaction forces in both the horizontal and vertical directions. And I'm just assuming positive towards the right and positively upwards. Okay, now let's deal with point B. B is also a pin support, so that means you're also going to have a force BX here and a force BY here, okay? Notice, just for the sake of simplicity, I'm just assuming positively towards the right and positively upwards. We can find out through analysis whether that's actually the case later, okay? Is there any other forces? Well, there would be if this bar had mass, would simply draw a force due to gravity at the centroid, but we're assuming they're massless, so that's it, okay? Now let's draw the free body diagram for this second beam just here. Don't let the shape of this beam confuse you. The principles still apply. Okay, well, let's deal with point C first. Point C is connected to a roller support, and a roller support is free to move in this direction in this case, which means the only reaction force can be in the vertical, and I'll call that CY. Likewise for D, D is also a roller support which is free to move in this direction, which means the only reaction force can be in this direction. Once again, I'm just assuming positively upwards. We can find out through analysis whether it's actually downwards or upwards, okay? Just based off whether it's positive or negative. Okay, and lastly, and probably most interestingly, we're dealing with point B again. Now, B is a pin, and it's connecting to both of these bars, and it would be tempting for you to draw a horizontal reaction force BX here and BY here, like we did for this first one. However, from Newton's third law, we know there has to be equal and opposite forces, so this is going to be BX, and this is going to be BY. If we defined BX to be positive towards the right this way, that means we're forced to let BX be to the left this way. Okay, now notice because both beams are massless, there's no force due to gravity here. Also notice that the 30 Newton force doesn't show up on this second beam because it's exclusively acting on this beam alone. Okay, Now, I won't be doing this in this particular video, but you can actually find out what all of these reaction forces are by applying Newton's laws. The sum of forces is equal to 0, and the sum of moments are equal to 0, but I won't do that. In this particular problem, we're only asked for the free body diagrams, so I'm going to leave it here, guys. Cheers.